Good evening, my name is Joanna Zamora. This presentation will be on conducting a correlational analysis for California Intercontinental University Class GRC 605, and today is February 3rd, 2019. Today's agenda will include an introduction, will include data analyzed, significant results, important takeaways, and we will end with questions and thank you. Introduction. I used the PSPP software to import dataset. Dataset was generated using SurveyMonkey. Participants are located in the Midwest United States, and a total of 150 responses were collected. The variables used were income, debt, savings, stocks, wallet, number of cars, number of credit cards, number of defaults, and comfort. The data analyzed, the variables were income and debt, income and savings, income and stocks, income and wallet, debt and savings, debt and stocks, debt and wallet, savings and stocks, savings and wallet, stocks and wallet. Once we analyzed all the variables, we found six significant correlations between the following. They are income and savings, income and stocks, income and wallet, savings and stocks, savings and wallet, and stocks and wallet. The first hypothesis test, the following correlational test was conducted. The null hypothesis found there is no correlation between income and savings. The alternate hypothesis found there is a correlation between income and savings. The correlation coefficient and its p-value were calculating using the PSPP, assuming R alpha equals 0.05. A significant correlation emerged. R equals 0.91 and P equals 0.00. The test rejected the null hypothesis and concluded there was a correlation between income and savings. Our second hypothesis test, the following correlation test was conducted. The null hypothesis stated there is no correlation between income and stocks. The alternate hypothesis states there is a correlation between income and stocks. The correlation coefficient and its p-value were calculating using PSPP, assuming alpha again at equals 0.05. No significant correlation emerged. R equals 0.19 and P equals 0.018. The test rejected the null hypothesis and concluded there was a correlation between the income and stocks. The third hypothesis test. The following correlation test was conducted. The null hypothesis stated there is no correlation between the income and wallet. The alternate hypothesis stated there is a correlation between the income and the wallet. The correlation coefficient and its p-value were calculating using PSPP, assuming again the alpha value at 0.05. A significant correlation emerged. R equals 1.00 and P equals 0.00. The test rejected the null hypothesis and concluded that there was a correlation between income and wallet. The fourth hypothesis test. The following correlational test was conducted. The null hypothesis stated there's no correlation between savings and stocks, and the alternative hypothesis stated there is a correlation between savings and stocks. The correlation coefficient and its p-value were calculated again using the PSPP, also assuming the alpha value at 0.05. A significant correlation emerged. R equals 0.28 and P equals 0.00. The test rejected the null hypothesis and concluded there was a correlation between savings and stocks. The fifth hypothesis test. The following correlation test was conducted. The null hypothesis stated there's no correlation between savings and wallet. The alternate hypothesis stated there is a correlation between savings and wallet. The correlation coefficient and its p-value were calculating using PSPP, assuming the alpha value of 0.05. A significant correlation emerged, R equals 0.91 and P equals 0.00. The test rejected the null hypothesis and concluded there was a correlation between savings and wallet. The sixth hypothesis test, the following correlation test was conducted. The null hypothesis stated there was no correlation between stocks and wallet. The alternative hypothesis claims there is a correlation between stocks and wallet. The correlation coefficients p-value were calculated using the PSP, assuming alpha equals 0.05. A significant correlation emerged. R equals 0.19 and P equals 0.017. The test rejected the null hypothesis and concluded there was a correlation between stocks and wallet. Important takeaways. PSPP is an efficient piece of software that can easily conduct a correlational analysis. The p-value is not the probability that any particular hypothesis is true or false. The p-value is a probability of obtaining the sample result if the null hypothesis were true. And this brings us to the end of our presentation. Thank you for watching. Any questions or comments can be posted below. I thank you for listening. Have a great day.